So as I said, these physics equation sheets are really important. Be very, very, very careful in terms of this equation sheet. And what I mean by that is, in physics, there is science and language that existed before what we could class as, modern physics and stuff. And there's words that are really old school and quite annoying. So the one I'm going to talk about is work done. Just let me max this out. So work done is exactly the same as energy and has the same units of the joule. All right. All right. So that's work done. So in these equations, you can see it how power has the same equation, energy divided by time and things like that. Okay. So that's key in this. All right. That's very, very key in this. In the work done is the same as energy. So watch out for your keywords. I bang it on every time. Underline the keywords. Pay attention to it. All right. Second thing, I really hate the units of watts, units of power. So units of power. I really hate them. Okay. And the reason why I hate the units of power is because we use this very historical unit, watts. All right. The truth is, there's a really cool one. And if you look at it, so I'm going to use one of these equations to show you. All right. A really cool one is power equals energy divided by time. Okay. And there's a reason why that's really cool. And the reason why that's really cool is if you pay very close attention to this, it tells you what to do. And what I mean by that is, that's just the time. Power equals energy divided by time. Now, time in physics is always seconds, right? So time is always seconds. And I might go through the units of physics with you guys just before we start. So power equals energy divided by time. Energy is joules. Joules divided by time, which is in seconds, and joules per second. That's why I love the unit joules per second, but we don't use that. We use the very old one, which is watt, W-A-W-T, W-A-T-T. That's annoying, and you've got to get kind of used to that. All right. Last thing, I want to really talk about units. The units you will use are always for mass, kilograms. Do not mix this up with chemistry. In chemistry, we always use grams. Length is always meters. Mass, I've done mass. Time is seconds. Missing one. No, okay, so time is seconds. So this becomes speed or velocity. That is distance divided by time, meters divided by seconds. All right, and I really like that, meters divided by seconds. Okay, now, and acceleration is meters per second squared. I can't do a little second squared. All right, force, the unit of force is always the Newton, right? And likewise, the unit of weight, so weight is a force. So weight also has the unit Newton. Be careful. Some people think, talking in normal language, which is, how much do you weigh? 97 kilos. That's English. That's general conversation. This is physics. Your weight is in newtons. So that's about the key things that you need to know. I'm specifically talking about energy here. So we've covered the language of energy. We've covered things like energy transfers, pathways. So what I want to do today is really look at, well, how do you use this information to answer these Unit 1 questions, all right? And they range from pretty easy to, oh my God. Now, and I went through exam technique, underlining keywords, for those, and I think a couple of you were new. So what I want to say to you guys that are new, or I haven't taught before, I don't know if you're new, I'm assuming you are. Okay, now, as you read questions, there are two types of reading, all right? And it's really funny. The GCSE in Physics was sat in November. The results came out last week. And I was actually talking to a parent. I had to analyse it. I get to analyse exam questions and exams and how she was doing. I was talking to a parent, and she was really upset. Someone's supposed to get a 9, he got a 7, and I looked at the work and I said, well, no, he should have really got a 7. And there's a problem with this. So reading, we assume there's only one type, and that's called passive reading. This is how you read a novel. All right? I don't care. I'm far too old in the world of reading novels. So yeah, we were reading novels and stuff. And I remember when Harry Potter came out and the whole school, I was, believe it or not, head of chemistry back then, and everyone was really into Harry Potter. That is passive reading. You don't really pay too much attention to it, or you just want to get a gist. You want to get a feel for the story. Now, what we do in science is something called active reading. And you are digging. You are digging for clues. What is the examiner asking me? Is there a clue as to what topic it is or what formula I'm using? This is active reading. All right? And what you need to do, and it's slower the first few times you do it, you need to develop the way that you think by analyze by performing active reading. Okay? All right. So how do we do it? And it's really simple. Underline keywords. It doesn't matter if you get the wrong keywords. You probably will. And that's where you got me saying, actually, no, that's the keyword over there. What you really are attempting to do in this is pick out words that are, so what do I mean by keyword? Keywords are those words that are, let me go here. Let me go to here. In your textbook, in your revision guide. And if you've got something like a CGP revision guide, there'll be those that are in bold. Okay. All right. Now, I think that covers everything. Take your time, underline your keywords. These start off rather easy and then get slightly harder and harder and harder.